Okay, and welcome back to the second video of this series looking at the design of a panel for Simpit. My name is TeaCypher, and if you haven't watched the previous video, this is a continuation of that. This is probably the third or fourth time I've attempted to record this video, so I've decided to cut it down a bit to make it a shorter episode. So, what we're going to be looking at. So just to recap, we're working towards creating a Simpit panel, and this is really just about teaching you some of the principles of design and sizing and such like, and how to read some documents. So this is our target I'm doing for the A8B Harrier for DCS. So going forward, this is what we looked at last time. We looked at what I considered the Bible back then, and just looked at some of the research. And then this time we're looking at the actual metal plate. Okay, so for starters, I would like to just make some clarifications and amendments to the previous episode I've done. After some feedback from various users on DCS Forums, they brought to light some problems with the Bible document I've been using, as shown here. I still fundamentally think it is a good document. It's just got some errors in it, and that part of it is down to, put it simply, it was written by someone who bases in metric and didn't get the transfers across. So the big ones that I've noticed, and I'll go into detail why I believe there to be errors. If we go back down to right to the bottom where the appendices is, 3 3/8, these 3 DCS is basically there's a problem here. If you look, he's gone 4 times 3/8 and given a result of 4.375 inch. That's incorrect. That's an error on understanding maths. These numbers here are correct. Okay, so the actual metric values are right. It's just the imperial values here are wrong. Also, I've found that there is a discrepancy between the suggested width of the holes against the mill standard, and I'll show you the mill standard in a minute. Yep, so this value here doesn't quite work right. So what I'll do, I'll bring you to next to the mill standard. So this is the mill standard that is for the design of panels. And with feedback, as I said, I've had feedback from other users, people who've got hands on real panels in America. I will say that in the UK it's very hard to actually get hands on panels, I find, and particularly the A8B Harrier, there's maybe 3 of them in this country, and most of them are hanging off roofs, and you just can't get into a cockpit to measure anything and do any direct real measurements. Okay, so this is the actual mill standard. It's mill standard MS25212 Charlie. This is actually a rescinded document now, so it's no longer up to date. As you can see, it's okay. It's not the best of quality though. So what I've done for my purposes and to be friendly to the community, I've metricized it here. Okay, and some of the main things to notice is this after protective finish, just how you read a technical drawing. As I by trade I'm a design engineer, so technical drawings is my bread and butter. You'll notice you've got 2 numbers here, 146.05 and 145.542. That means the dimension can be anywhere between those 2 values. In the original document it talked about a width of 5.75 plus 0.000 minus 0.020, so that's why this 146.05 is actually 5 3/4 of an inch. Yep, and the other very important thing to note is this after protective finish. So this value here is after it's been painted, it's got a protective layer on and everything else. So when we're dimensioning, we need to make sure we have smaller dimensions to make sure we can actually the paint and stuff doesn't go beyond this region. Talking to my contact, he tells me that the measured width he normally reads is 5.74 inches, so which is less than the 146.05. Yep, so this side basically I've done a reference to the original mill spec. I've copied the stuff for the plate itself. I've not worried about the actual depth of the boxes or anything like that. If you really want to go into that, you can go to the original mill spec and have a look at this. I will hopefully put a link to both these documents in the description. And then finally over here we just have a list of the DCS size quantity, so 3 all the way up to 16, and then we've got the relevant distance A, which is the total height of the part, plus or minus, so use plus 0 or minus 0.762 millimeters, and then this B value, which is the distance between the mounting points. Again, this is plus or minus 0.127, so that doesn't matter so much. And then here we just got a reference to how we actually find those values. So A is the Zeus quantity times 9.525. This is pre-tolerancing. And just to reiterate, if you use these values, your panels will fit together. And then A is the how we get to the sorry, B here is how we get to the gap between the two studs. And then here we just have a couple of references into how edge cases are. So if you just got 3 de Zeus, this is how your panel will look. And if you've got 2, you end up with this offset situation here. And the key is the offset between these 2 points. Okay, so just moving a bit forward one with this little document I've done before we go into the actual presentation. If I scan down, what I've done on the second page is what I'm going to be using for my dimensions. So I've gone, okay, that's what the mill standard says. These are the values I'm going to be using, and these are based on having a 0.2 millimeter gap on all edges, so 0.4 millimeter gap total once you add those together prior to painting. I did a little bit of research, and I believe that with paint, 2 layers of paint and 1 of spray paint, you should still have, this should still fit together. Talking about this value here, so this value here is the basically we reference between the center points of the holes, because that's how you mount things, and this distance here sets the reference here. In the document it's referenced from the bottom. Now my contact actually tells me he finds the gaps normally at the top, so that's an interesting little fact. So yep, something to be aware of. And in all honesty, when I do my panels, I'm not going to use this. I'm going to choose to use a symmetric reference to ensure we have the same gap top and bottom. That's my choice. That's a choice you have to make. So again, like I said, this is just a set of dimensions I'm going to be using. I haven't had a chance to actually physically test this, so your choice. You could choose to make them slightly smaller, up to you. So back to what we're doing in this particular one again. So that was the clarifications and amendments. So I did mention I'm a design engineer by trade. I've been doing it for 15 plus years. I've used programs such as SolidWorks and CATIA, very powerful, used in aerospace industries and other industries. For this, we're going to be using Fusion 360. Why Fusion 360? Simple. It's free to hobbyists. So you can't use it for commercial gain. You have to pay for it to commercial. But as a hobbyist and someone doing it yourself, it's free. It's not as good as SolidWorks or CATIA, I don't think, but it's close enough and it does enough for what we want to do. So looking at Fusion 360, excuse me. So this is what we're aiming for. This is, as I said before, I have already created a panel. I'm actually going to amend it because since I mentioned your design, I actually designed this to the wrong values. I designed it to the max values and not the ones to account for painting and stuff. And there were other amendments I want to make to this design, so I thought I'd step through how we do it. So first things first, creating a new drawing. So what we do, you should open up, when you open up Fusion 360 for the first time, it will say a untitled document. Okay, you can create a new one by just clicking this new design here. Okay, so from that I just need to quickly bring up my document for referencing purposes, put it to the side. What we're going to do is we're going to create a drawing. Okay, so in this section here we see the features for creating parts. So I'm just going to create a new sketch. Okay, and I'm going to put it on the top plane. Okay, which is this one just here. Now, when we're modeling stuff, we normally have 3 planes. We have top plane, side plane, and front plane. Okay, and we have 3 axes. We have x-axis, z-axis, and y-axis, as can be seen in the little drawing up here. Okay, now what we're going to do, we're going to create a simple rectangle. So I'm going to select this 2-point rectangle thing and just one click, left click, jog it out a square. You'll notice it's giving dimensions. That doesn't matter at this point. We're going to dimension it separately, and there we have a basic rectangle shape. Okay, so for the part I'm doing, I have had a good look at this and I've decided that the actual DCS count for this is 9. So going back to my document here, I can see that I need a Charlie height of 85.325. So 85.325. How do we do that? Okay, going back to Fusion 360, we select the dimensioning tool. So click on there, and we've got two ways of dimension. I'm going to show you both ways. I'm going to show you probably what the first way everybody would come to dimensioning stuff would be. So you just click on the line you want dimensioned, drag it out, and click. And now you have the dimension. Now the C height, Charlie, is going to be 85.325 millimeters. Bang, there we have it, the first dimension. Okay, the next dimension we're going to look at is the width height. Now for this one, I'm going to show you a slightly different way, and this is my preferred way of dimensioning stuff. It's just the way I was trained as a designer. With that one, you want to select the first side you want to dimension between. So I'm selecting that one. Then you want to select the second side. Bang. And then you can click up. Okay, so there we have it. And for that, we're going to use 145.65 millimeters. Bang. So now, if I click Finish Sketch, we have our basic shape of our panel. Okay, now how to edit a sketch. So you've got two ways. You can right click here, click Edit, or you can right click down here and click Edit. I'm going to do it at the bottom. It just seems to work better for Fusion 360. As you can see, we're back in the drawing. So the next thing I'm going to put in is the holes for the DCS, which can be seen. So I'm going to click around quite a bit. Just here, 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 and here. Okay, so what I'm going to do, I'm going to start by doing something slightly different actually. I'm going to draw some what we could call construction lines in. So I'm going to find, and you see how this little triangle shape's appeared above the cursor when I've rolled across the line? That marks the midpoint of the line. I'm going to bring a line all the way down and select there. I'm going to do the same on the side. Okay, these are for what we can call construction purposes. So if I click Escape and then I click on both lines, Control to select both of them, I can then on the right hand side turn them into construction lines. Okay, these are for references purposes, and I'll show you how I'll use these in a minute. So I'm now going to create the actual holes themselves. So there we go, circle, bish, bosh, bash. Okay, 4 circles. Okay, so these are our holes that we're going to be mounting the plate with. So I'm using an M4 screw and using a tight clearance fit. That tells me it's 4.1 millimeters. You can find the clearance value of a screw online. There are various different sources. I use a little handbook called Zeus, which tells me the clearances and everything for holes and things. And this could be anything from 4.1 for a tight fit up to 4.5, 4.6 for a loose fit. I'm going with a tight fit for this. Okay, now what we can do, instead of having to type in 4.1 4 times, what we can do is start to use these constraints functions. Constraints are very useful in drawing stuff. So what I'm going to do, I'm just going to select equals. I'm going to select the first object, and I'm going to select another object. And you can see, once you've done that, they are equal values. So their diameter of 4.1 millimeters is the same. And I'm going to repeat that for all the holes. And with that, if we ever want to change the size of the hole, and I can just press escape to leave that equals function, I just have to change it once and all of them change, which is very useful. Okay, next function I'm going to use, and again this is a constraining function, and it's based on the way I've designed. I'm modeling this up. Okay, I'm next going to use this symmetry function. Okay, symmetry basically it means that it's like a mirror image effectively. So I'm going to select symmetry. I'm going to select the first object, the second object, and the center marker, so the center line here. This is where this midpoint line really comes in useful. Okay, by selecting that, now these are basically mirrored along this line. I'm now going to do the same for the other parts. And by doing that, if I come out the equals there, if I move one, they all move, but they're always moving in relation to the construction lines I've put in place. Okay, so final sets of dimensions. Okay, so sketch dimension now. So I'm going to press escape to deselect the item I've already got. Okay, and I'm going to just dimension the distance between these. Okay, now looking back at my document for 9 Zeus, I know the distance between these holes should be 57.15 millimeters. And that's wrong because I'm looking at the wrong number. It should be 136.271 millimeters. And then this height should be 57.15 millimeters. Okay, so now we can see we have our plate and we have our 4 holes. Now what we can do, we can put additional dimensions in here. If I was to drop a dimension in here, I'll get error message saying, oh, this is over constraining. Do you want this to be a driven dimension? I can click yes. Basically, what this means is if I change this dimension to something else, it'll automatically correct to show you what the measured dimension is in that case. It can be useful if you're trying to work out things. And just for reference, you can actually put in dimensions as imperial, so that should be 1 inch, and that instantly jumps to 25.4, which is an inch. Just a useful. You can also do formulas. Actually, you can do 10 plus 10. Yep, and you can use brackets and things like that. So it's just a useful way of creating values, and you can actually drive them off other dimensions. So you can actually go, I want that dimension to be that, and then enter, and bang, it goes to that. So useful features with new dimensioning. I will say there's plenty of YouTube videos about Fusion 360 out there, and quite a good community to help, so you should be able to find some information out. Now you can see this 14.088 is not exactly the same as the dimension on the reference document, but this will give us a gap of 0.02 all the way around this, which is what I'm aiming for. If you're working with some real panels, you're probably going to have to actually work out where their gap is and adjust this value, and maybe not make this symmetrical across here, but just a simple dimension to create the gap where you need it to be. Okay, so we have our basic shape, and then the final thing we're going to do, we're just going to extrude it. So I click on the extrude, I click on the what we're going to extrude, and in this case we're going to be extruding it, for me, 2 millimeters. Bang. And there we have it. It's as simple as that. We have our plate, and we're one step towards the objective. What I'm going to do, hopefully, is I'm going to provide a link to a folder full of an entire set of plates. I have added extra screw holes here. This I'll explain in a later video. Is how I'm going to be mounting the acrylics. And I've also added a random point over there, and again, this is for future references and future purposes of my manufacturing process. But I hope you have found this video interesting. I will upload and provide links to the PDFs I've been using, and I will upload the pre-made models I've made for the basic shapes, and provide a link in the description below. Any questions, please let me know. Please visit the DCS forums. There's a great community there about pit building. I will say I can be wrong, this is just my impressions, but thank you for your time, and I hope you enjoyed.